Now I want to discuss the words that are actually used in Cathodic protection theory, because I find these confusing. So I've no doubt that all of you find these confusing. What I'm referring to is ions, electrons, energy, potential, and amps. Everybody knows what volts are because you read them on the meters. But ions, if you look it up on Google, you'll find it's described as charged particles or charged atoms. And then they mention cations and anions, meaning negative charge in charged atoms and positive charged atoms. This is all very well, but we cannot measure ions. There is no such thing, to my knowledge, as an ion meter. But the term is useful because, in fact, we measure charges on all our meters. They measure charges. So it is convenient to know about ions, and we must know about electrons, and we must know about potential, what that means, and amps. So, just briefly, ions can equal charges, electrons can equal small particles, energy can equal waves, the amount of energy is potential, and amps is energy travelling. So if you have a potential travelling through an ammeter, and then it can go on to two atoms or items or whatever, and if there is the same resistance in equal parts of this circuit, this will be half the potential of that, that will be half the potential of that, so they will equal 1, and according to Kirchhoff, this is a node in this system, and therefore the ins and the outs equal 0. Okay, now we come on to the matter of discussing ions. An ion, according to the definition, is electrically charged atom or particle. We cannot measure an ion, but we can measure electrical charges. We can also see colour changes in particles resulting from the corrosion reaction. So it is useful to know that. Electrons. We cannot see electrons. They're too small. But we can see their paths. We can see where they've been. They're like snails, they leave a trail wherever they go. So, and this is the principle that we use in oscilloscopes, right? And the original CRT, CRT, cathode ray tube, yeah, CRT, was X-rays which are bounced off platinum, and the electrons hit a screen which is treated with lead oxide or something like that, and as the electrons pass across the screen they leave a trace which we can see by looking at the screen. Okay, but quantum theory has introduced confusion about electrons because of famous experiments where electrons were passed through slits, and apparently electrons can be in two places at once, and this confused everybody. And it didn't actually confuse Einstein, but he was one of a group of people at the Copenhagen conference where people like Max Planck and various other people discussed all about quantum theory and how it worked and all the rest of it. Now, quantum theory is very useful, but it is an approximation, the same as calculus and logarithms and various other bits and pieces in mathematics. So quantum theory has proved very useful in the advancement of science, but there are still arguments about it and it is still not definitive. And to prove this, we have the Large Hadron Collider at CERN in Switzerland, and that was looking for what they called the God particle. And this was put forward in a theory by Higgs. It's been called by some people Higgs boson. And what they were looking for was the root of the production of matter out of nothing. And at one stage they have claimed to find it, and it is, as Higgs described, a field. It's like a thought or an idea in a crowded room. It spreads through the crowded room and it has an influence of making that thought into something which is solid and which can be calculated and in other words, the thought becomes mass. It can be weighed. But although they claim to have found the Higgs field, the Higgs boson, it has gone no further than that, and in the last 2 years they have been looking to do something more with this information, and they can't. So I'm following this very closely, and all the information is on the internet, so this is great. Right, so the next thing is, what is energy as far as we're concerned as corrosion engineers? Energy is visualised as waves, and electrical energy is controlled through conductive circuits based on this principle. Energy is one of the 3 components of the corrosion reaction. It can be described as a triangle. You have metal, you have chemical, and you have energy. Okay, that's the end of this section of this video.